Hello and welcome to the Chandara Academy. Today we're going to solve this 2022 exam exercise about complex numbers. So this is a really easy exercise. You just have to be rigorous with your calculation to not make any mistakes. So we've got a complex number z1 is equal to I times 3 plus 2I times 2 plus I squared. Okay, so the first question is to write z1 in an algebraic form. So, a sum of some real number plus I times some other real number. Okay, so we just have to develop the initial expression. Okay, so let's do it step by step. So, z1 is equal to, let's distribute this y, not forgetting that I squared is equal to minus 1. Okay, so we've got z1 is equal to 3i minus, so the minus comes from the I squared, minus 2 times 2 plus I squared is equal to 3i minus 2 times, so 4 plus 4i plus I squared, so that's equal to minus 1. Okay, so we've got 3i minus 2 times 4i plus 3. So let's develop that. So we've got minus 12, so this development, plus 9i, minus 8i, minus 6 is equal to minus 18 plus I. So z1 is equal to minus 18 plus 1. We want now to find the conjugate of z1. So z1 conjugate. Let's remember that when a complex number is written into its algebraic form, so z is always written as a plus ib, with a, b, a real number. So when we want to find the conjugate, it's really easy. You just have to take the same real part and you just have to take the inverse of the imaginary part. So a minus ib. So for a number, we've got z1 conjugate is equal to minus 18 minus I. Now, next question. So we answer the question. Next question. We want to compute z2 to the fourth and z2 to the sixth power when z2 is equal to z1 plus 19. So z2 is equal, let minus 18 plus I, because this is regular z1, plus 19 is equal to I plus 1. So to do that, we want to elevate a number, a complex number, to some kind of power. We want to have it in its trigonometric form. So how to do that? Let's find first the module of z2 is equal to the square root of its real part squared plus its imaginary part squared. And when written in the complex plane AB, so with z2 here, for instance, so that's totally a random z2, this is equal to this, so the module is equal to this distance. And why this formula? Because here we have a right triangle and we're just applying with the real part and the imaginary part the Pythagorean theorem. Okay, so here is equal to square root of 1 plus 1 is equal to square root of 2. Now, let's try to find the argument of Z2. So, when written in the complex plan with A, B, so now we're going to do this scale. We've got one I here, we've got, so one here, we got one here, and so we've got our number Z2 here, and the argument will be this angle. So with a 1 and a 1 here, it's really easy. We'll find pi over 4. So half of pi over 2, which is here. But how to find it? Generally, we've got argument of Z2 is equal to the arc tangent of the imaginary part of Z2 over the real part of Z2. So plus or minus, because let's remember that arctangent will have two solutions. So for instance, for this problem, Z2, but also the symmetric of Z2. So let's call it Z2 prime. This will have the same arc tangent. So let's write it down better. So arc tangent. But how to differentiate the two? Just by writing Z2 into the complex plan and choosing between pi over 4 or 5 pi over 4. This is clearly, the result is clearly pi over 4 because Z2 is like this. You've got a positive real part and a positive imaginary part. So we are on this side. Okay, so here it's equal to plus minus arctan of 1 is equal plus minus pi. So no, not plus minus. So is equal to arctan of pi of 1 is equal either pi over 4 or 5 pi over 4. But as said, the solution is pi over 4 because we are in this part of the complex plane. Okay? So the solution is pi over 4. So arg of Z2 is equal to pi over 4. So now let's write Z2 into a trigonometric form is equal to its module, so square root of 2 times exponential of I times the argument pi over 4. Okay, and now it's really easy to compute Z2 to the fourth is equal square root of 2 to the fourth times I pi over 4 times 4 is equal to 4 times I pi, and if we look at the complex plan with the real part here, the imaginary part here, with a radius of 1, the regular thing, we got I pi, so here is equal to minus 1. Okay, so we got minus 4 because I pi is this point. So Z2 to the fourth is equal to minus 4. Now same thing, Z2 to the 6 is equal to minus to square root of 2 to the 6 times I pi over 4 times 6 is equal to 8 times I I pi times 6/4, so 3/2. We've got this point which is minus y, and so we've got z2 to the 6 is equal minus 8 times I, so z2 to the 6 is equal to minus 8 times I. Always refer to the trigonometric circle, okay? And now we've got all the solutions to our problem. Hope you enjoyed the video. Bye.